इसका चैट बॉक्स ओपन कर दो जो नीचे। हाँ, बस ठीक है, सेम छोड़, पढ़ता रहूंगा साथ में। ओके, सो टुडे morning we basically discussed like economic load discussed with and without losses, and I have rewritten this entire formulation here again. So if I you look at this particular part, so we are basically minimizing with respect to the pi. Okay, with respect to pi, basically we are minimizing, and then this is the cost function. So today morning we discussed like it's a CIPI is a function, so I have expanded it AP square plus BP plus C, and then subject to whatever is the power demand plus losses equals to summation over pi. This is power balance equation. Then this loss function is defined here. So this is the standard loss function. Usually, like if you see some textbooks, only square terms are given, and that too, like like pi square one, p2 square, p3 square, and so on. Not even the like p1, p2 cross terms are also not given, which means that respective terms are zero in that function. So this is the loss function given, and then we have minimum and maximum limit. So this is our full economic load dispatch problem. If I talk about like what are the input data to this particular problem, so you can see like for each generator some coefficient A, B, and C will be needed, and for each generator there will be some minimum and maximum generation limit will be needed. Okay, so we have defined like A, B, C are parameters here, input parameters. Then power demand is there. So I have mentioned like the power demand is also needed. Then P loss is a function. Pi is also variable. So P loss is variable where Bij, Bi note and B double note is needed. So we are going to need all the B coefficient. Just to go and see how our program will look like in game. So I have a certain games code, and we can see here that so if you see, let's see if I can zoom it out. Yes. So we understood or we learned that okay, we have to write it down like very fundamental games code we discussed in the last class, second last class. Today we will talk about like different sets and the member of those sets and how to use them and how generally a code will look like. So we have defined a set here, that what will be the set. So this set has been defined here. So we have defined set I. So we also used pi. So the same I is the set. It represents the number of generators, and we have defined that P1 to P3 are the three generators, just like the example we sold in the morning. Then some generator characteristics are needed. So this is the description. This is the set defined generator characteristic, and these are the different members like coefficient A, coefficient B, coefficient C, upper limit and lower limit. So P max and P min is given here. That okay, these are the characteristics. Then one more attribute is defined, which is called cost categories. Okay, so like it is basically a subset of the first set. So this generator characteristic is one set, and CG is basically a subset of generator characteristic, and only ABC is being used in this particular set. Okay, so we have basically created another set out of a master set. Then we have created a duplicate copy of the set I. So it is J also represents P1, P2, P3. So now the input data, as we discussed earlier, the input data will be, okay, wait, let me stop and share my entire screen so that whenever I toggle, you should be able to see it. Okay, so first of all, like what are the different input data? So this is our input data. Like for each generators, A, B, C, and P min, P max should be given. So this has been here basically mentioned. Like P1, P2, P3 are basically different sets. So these are the P1, P2, P3. What is the A value, B value, and C value? Then upper limit and lower limit. Uh, in this code, basically, what we did is we, instead of a as a p square, we have reversed, like as per the data I can see. So let me correct this one, so I can, like, in many books we use a as a coefficient of p square. Sometimes we use c as a coefficient of a square. So let me correct this one. It is bp plus c p square. Okay, so sometimes we write it like this as well. So it's same. You can name A, B, C to the coefficient, but the standard are basically the way I'm able to identify. Usually, A has very large value and C is like in fractions most of the time, like from the practical data set. So that's why I was able to see that this coefficient is with respect to P square. This is with respect to P, and this is the with respect to our like constant coefficient in the cost function. Then upper limit is 2000 to 200 and lower limit is 50. Similarly, for second generator is 150 and 37.5 and 180 and 45. So this is an example from Wood and Bullenberg. So I'm using the same example. Then some parameters are defined just to mimic the power, that what will be the power. So P exponential and the CG cost categories which we have defined here. For those cost categories, we have defined a parameter, and you can also define like this. Okay, so as we discussed earlier, that we can define it like this as well. So okay, so this is also it can also be defined like this. So let me save it. So here, like A is 0, B is 1, C is 2. So C is like second power, so second order derivative. So these are the powers basically, like AP square, AP power 0, B power 1, and C power 2. Then okay, wait. If we further proceed, that another data is basically this coefficients bij. So this is bij is a matrix, bi naught is a array, and b naught naught is a single scalar. So this is what basically we are mentioned here. So this bij is the first parameter, like square. So p loss coefficient is squared component, and this is like between pii. This is the bii, bij 12, b13, b21, and so on. So these are the different coefficients. Okay, so this is how we provide input to this particular parameter table basically. Then it is a array. So parameter is basically the syntax which we use, and this is bi note. So this is b note I. So this is bi note. These are linear coefficients, and with respect to p1, the coefficient will be b1. So this is b1, this is b2, and this is b3, or you can call it like it's a b1 note, 2 note, and b3 note. So these are like this b I note is like B one note, two note, and three notes, because we are going to sum it over I. So these are the coefficients here. Okay. If you have any doubts, you can put that into chat. I'm actually looking at it, so we can discuss in between as well. Then further, we have two scalars. One is demand. So demand is defined like demand is 210, and then scalar is the B naught coefficient. So this is what B naught coefficient is given. Okay. Now what are the variables here? So if you look at this particular part, we have defined Pij is a variable. Only Pij is a variable. But if you see, this P loss is also a variable, and it is basically equals to some coefficients multiplied with pi. So this p loss is also variable. Pi is the output of the optimization, and p loss is basically an internal variable which is being used in this entire basically formulation, and this is equals to the total cost. Okay, so this total cost is basically provided by this variable cost function. So cost function is equals to basically total generation cost or the objective function. Loss is basically our P loss, so it's a transmission loss in megawatt, and Pi is the power generation level in P1. So like in the very first one we defined like this. So we defined multiple variables here, like yesterday, that like P1, P2, P3, P4, and all the variables separately we defined. Here we defined with, so instead of like defining it 4 times, if you see in this particular code, we have only defined 1 time, that Pi is the power generation. That's it. Okay. So this is the good thing with sets. So within a set, you can define multiple variables. Then we also defined that P is the positive variable that cannot take a negative value. And then we have to mention upper and lower limit, right? So the upper and lower limit is provided here in this particular table, in which the input we have provided. So in table generator data 1, 2, 3, and 4th column with name upper limit is the limit of the generator is provided. So we can basically use it like this, that p dot up for each ith generator is equals to generator data respective I, and column is upper limit. So it's basically row comma column. So this is how we can set the upper limit for all the generators, and this is how we can set the lower limit for all the generators. Instead of what we did yesterday is we defined it 4 times, the upper limit. Even for demand we defined it 4 times, and we had a zero limit yesterday. So we did not define like lower limit. Otherwise we have to define 4 times the zero limit as well. But yes, by doing so, like by defining positive variables, we already defined it. So that's why we have not written it yesterday. Now the p low is also defined from that table. So this is how you can easily define the variables. Then next part was we have to declare certain equations. So I have declared 3 equations. So if you look at this formulation, one equation is basically this, so your objective function. So this is equation 1. Then we have equation 2. Okay. And then we have equation 3, which is loss equation. These limits has been already defined. So this we don't have to define anymore. So this has been defined by lower and upper limit on the variable in the game. So these 3 equations we have to write it down. So if you look very carefully, this is like the TC, total cost, or the objective function, is equals to summation over I and AI plus BPI plus CPI square. The same thing has been written here. So the cost function is basically our cost. So cost is equals to the same thing, summation over I. Okay, and we have written that instead of so summation over I and CG is basically for each generator. Okay, so there will be like 3 generators, so we have to write it down for 3 times. Okay, so and I can write it down like 3 times, like a p square plus b p plus c p square. So 3 terms will be needed. So to avoid those 3 terms, we have defined a CG as well. CG has the values of A, B, and C only. So basically, we are summing over I and ABC. So ABC we have simply defined like generator data I comma CG. So it is basically for I comma A, P1 comma A, and multiplied with power of Pi, and power will be provided from the exponential. So for A it will be 0, so that is the constant term. Then for B it is 1, so that is your linear term BP. And then for C it is your square term, so the quadratic term in the cost function. So this is how you can simply write it down, the cost function. Loss function, this was the loss function. P loss is equals to summation over I, summation over j, I, Bij, and Pj, plus summation over I, Bi naught, Pi, plus B naught naught, B naught naught. This is what we have written here. The P loss or loss is equals to B naught naught is the scalar, so we have defined it in the very beginning. Then summation over I, Bi naught, Pi, okay, plus summation of just a second. So then summation over I and j, Pi, Bij, and Pi into Bij into Pij and divide by 100. So this is basically just to see. Okay, some cost coefficients are also provided here. That what will be the cost coefficients. Then we have basically some demand. Our power balance equation. So it is P demand plus P loss is equal to summation over Pi. So you can see here, this is our demand function. P demand plus P loss is equals to summation equation 2. So we have mentioned it here as well. So demand function is defined. Now some interesting parts are there that how we can solve it. So as we discussed that the economic load dispatch is usually minimization of cost. So we have like defined a model. So I will put it like, let's say, underscore without loss and underscore without loss. Yes, we will check about it. Where was the lambda earlier in our notes? What was the lambda? Lambda was the dual variable of equation number 2, right? So we will see what is the lambda and how it will come in the games, like where can you find it and what is the significance of it. We will see. So model without losses, and if I run it, you will see some LST file is open, and in sol variable you will get the variables like the P is basically between is at 58, P2 is at 38, and P3 is 121. Okay, so these are the values which we have obtained in this particular code. So this is without losses we have defined. Yeah, with losses, sorry. So okay, I made a mistake. This was our objective. So we are going to solve whatever model we have defined in this particular line. So this is our model. So we solve EDC with losses. The objective is to minimize. And what we are minimizing? We are minimizing the cost. So cost equals to summation of this. So we are minimizing this total cost. Okay, this part here. So we are minimizing it, and method is using no linear programming because we have square term, so it is no longer linear. And if we run it, then there's some solution will come, and that will be equals to like P1 is 50, 75, 93, and then if you see. Okay, so if you see here, then some certain like this level value represents the actual value of P. This is lower and this is upper limit. Now, what is the equivalent of lambda? So lambda, to see the value of lambda, we have to see at solve equation, this part which I have opened right now. And so there are three equations basically. So let me click first equation. So we had a cost function equation, then we have a loss function equation, and then we have a demand or power balance equation. and in power balance equation this some marginal value is coming. Okay, so this marginal value is basically the lambda. This is the dual variable of the, so the lambda value is 13.0442 for the this particular problem. Now what will happen if instead of minimizing cost, if I put the loss? So like, to change between problems, as I explained earlier, that you can define it differently. So let me define another equation which is loss function 0. So at line number 52 I have defined loss is equals to 0. So we had two formulation, one is without loss, another one is with loss. So for without loss I'm going to use this particular equation. So before defining it I have to declare it as well. So I will declare it here. So this is where I have defined it. Sometimes the dual will represent the market price. How does marginal value will be interpreted? Yes, I will go into that part. And let me tell you, if our objective is of cost minimization and social welfare maximization or profit maximization, then the dual variable with respect to power balance equation represents market price. So I will update the same code to solve the market clearing as well. Okay. So here, if you see, instead of instead of one equation, I have defined two loss function. One is the proper loss function with b coefficient. Another is zero equation, and I have declared that particular equation as well. Then let me comment these one. So by star you can comment. Okay, in the beginning of this one, and let me uncomment these. If you see, I am modeling a EDC without losses, first of all. Okay, so here at line number 58, I am modeling without losses. So if it is without losses, then loss part will be 0. So what I can do is, I can use equation which is cost function at 49. Then I can use a demand constant which is at 51, and then a constant at 52, because where losses are 0. So this is how I have defined that. Okay, the instead of defining all, like as at line number 55 we have defined all constants has been considered. Now I am defining that one constant is cost function, another is demand constants, and then zero loss constant. So losses are 0. And then with losses, if I want to solve, I will define a EDC, economic dispatch controller. So with losses, here I have defined cost function, demand constants, and loss function, which is basically our proper loss equation as per line number 50. So I have created two models within the same piece of code, within the same with the same information. I only just added one more equation. Okay, now I can solve them as well. So EDC with losses I have been solving, and then EDC, let's say first of all solve without losses, and we are if it is without losses we are minimizing cost. Okay, then in so in 61 number line we are solving the model without losses and we are minimizing the cost here. Then at 62 we are solving EDC with losses, again minimizing the cost. Sometimes we perform loss minimization objective as well, with the same have to minimize the losses. So what I will do is I will write down the same equation. So if the objective is loss minimization, I will simply write it down like this, that just minimize the losses, that's it, nothing else. So this is the same problem like with losses, so everything is the same, and I will replace the minimizing the losses. And if I solve it, so I will hit the run button, and I will open the output file. So you can see there are multiple basically uh, like files are there. First, we basically had without losses. So if you see the variables, the output is 50, 88, and 71. So this is the without losses output. So there was no losses, and the lambda was okay. So let me note down these values because it is interesting. So the very first model was with without losses. You can see the loss value is 0 here. Okay, variable loss is 0 because we have provided loss is equals to 0, and you can see the variable p1, p2, p3 is 50, roughly around 88 and 72. So I will put it down here. Let me put it here that for this example, uh, case 1, variable represents incremental cost in this scenario. Does dual variables represents incremental cost in this scenario? We will come to that part as well. If you have missed the class earlier, and if let me go back what we discussed in the morning. So you can see here this particular part. So this is like our simple economic load dispatch. We have written the KKT conditions, and this term is also called as a incremental cost or the first order derivative, and by this equation it is equals to lambda, and lambda is defined as a dual variable of power balance equation. We have defined lambda as a dual variable of the power balance equation. Earlier in the morning I told you that this can be treated like a penalty term, or it is basically penalty coefficient, but the significance is this is basically an incremental cost. So like for all the generators, this equation will be written down like we discussed, like number of generators. So whatever the number of generators, we have to write it down the same equation multiple times, and it means that all the incremental cost will be equals to lambda. So the lambda is basically the incremental cost, we can say, and the incremental cost remains same all generators. But we also discussed earlier in the morning that if we change the power production, then the let's say like for this two generator example, the upper limit has been violated, so we fixed it to 50, and if with this particular 50, if I put those in the upper equation, lambda was coming out equals to 3.8. So now this is like whenever the limit violates, its incremental cost is no longer equals to the lambda. Okay, so this is 3.8, but for the second generator, limit is still within the range. So whatever is the lambda calculated by the generators which are floating basically between the minimum and maximum limits, lambda is given by those generators only. If they are violated like at the maximum and minimum level, then the calculated lambda from those equations is nothing but the incremental cost only, and it is not actually equal to the system incremental cost. Okay, so this particular example, we have obtained what was the values? Just a second. So it is 50, 88, and 72. So I will put it here: 50, 88, and 72. And then lambda, how much is the lambda? So let me see. So lambda, we defined it's a marginal value at the dual value of the equation. And what equation it is? Power balance equation. So I will go at the equation, and this is my power balance equation. So if you see, it is the marginal value is 11.9, I can say. So I will put lambda is basically 11.89. Okay. Uh, Let me do one more experimentation here. What we can do is, so we have defined losses. Okay, how does it look like? So if I see how this equation looks like, so if you see, the equation is basically minus p1 minus p2 minus p3 plus losses equals to certain demand. Okay, So it is basically negative demand. So this is how it is basically treating the demand as a like on the right hand side. So it moves everything on the right hand side. So that's why the lambda which is coming out of when we solve this particular equation is basically a negative value, but it is not actually. So this is actually 11.9 or 89 only. So this is lambda, and this represents the market clearing price as well. So earlier, when we discussed yesterday, we discussed market clearing. So we can do that with this particular code as well. And let me first move or see the second result. So if we see the second result, it is again minimization of the cost, but with losses. So whenever there are losses, so losses are 8.78. So earlier it was 0, now 8.75 is the losses, and 50, 75, and 93 is the answer. And if I see the lambda as well, so lambda, what should happen to the lambda? Will the lambda increase or decrease if I consider losses? Let's say lambda, and lambda is market price, or you can say system price in this particular case. Like in the economic load dispatch problem, we can call it system price as well. And if you are solving market clearing, then we can call it market clearing or market price. So will the lambda increase or decrease? So if it is a system price, we discussed the supply demand balance, which gives us the market. So whenever there is a more demand, the prices will increase. So if there is no losses happening in the system, or in the modeling, we assume that there should be no losses. So if there are no losses, demand is obviously the same. We whatever we assumed here, okay. So roughly around 210, and if losses are there, then demand generators has to supply those losses as well. So they have to produce more, and if they are producing more, then they have to basically uh, the cost will increase. So the cost has been increased to 13.04. So let me write it down here, that lambda with losses has been increased to 13.04, and some increased values has been here as well, which is roughly around, like if I look at these values, uh, 50, 75, 93. So I will put it here, 50, 75, and 93. Right? So this is the relationship here. Like, can we observe something? And let me just put down the third objective as well. Like, when we considered only losses, what will happen? So if I see only losses, then it is 58, 38, 121. So let me put it this 58, 38, 121, and let me see the lambda as well. Like, as it has no significance, but it is hardly like 0.07. Okay. So if the objective function is changed from cost minimization or from the social welfare maximization to the loss minimization, it no longer represents the price. So that's why it is basically the marginal pricing with respect to the losses, not with respect to the cost. And the marginal cost is system price. Okay. So the variables has been okay. So the variables has been mentioned, like it is 58, 38, 121, and losses. Yes, let me see the losses. So the P loss is basically 7.9546. So how much is the losses? 7.9546. Or I made a mistake. 7.9546. Or earlier the losses was 8.74, 8.74, and here it was 0 because we have assumed it 0. Now, can somebody tell me like what is the like this signifies? So this we have already discussed that as there are losses, so losses will increase the system price because the generators has to supply the losses as well. So that's why the lambda has been increased. But why the first generator is kept at minimum? So if you look at the data, what does it say is basically, let me go here, go on the top data. So this is the minimum limit. So like first generator is setting it to the minimum limit, which means this is very expensive generator simply. Okay, and I can see it as well that this starts at very high cost, the linear cost, and yeah, so that depends upon the cost function. And by looking at the results, I can say that this generator is expensive one. Okay, so by looking at the results, we can say this is an expensive one. That's why we have set it to the minimum level and not even a zero point 0.1 more than the 50 megawatt, which is the minimum limit. This is we can say expensive generator. Now, what happened here? Like this part has been increased. This has been increased, and this has been decreased. Can anybody tell me why this is happening? Anyone? Why this is happening? Like this generator 2, like if I look at compare these two generators, uh, they are almost similar generators because they are producing roughly around the same quantum, 72 and 88. Okay, so like in the same range, but the second generator's power output has been reduced and the third generator's power output has been increased, and that is this is like without loss, and this is with loss. Anyone who wants to answer? Yes, anyone of you? Why this change is there? Yes, thank you for the answer. Loss coefficients. That the loss coefficient with respect to second generator may be very much high, and it is creating very much high losses. So that's why the power output from the second generator has been reduced. Because what will happen if the losses has been increased, then to supply those losses we have to produce more, the power generation will be increased, and if power generation is increased, the cost will also increase. Okay, so that's why basically we are trying to minimize the cost. Our objective is to minimize the cost in this particular. So that's why that this particular generator output has been reduced. Same like if you further, like if you keep the objective of loss minimization, it is further reduced to 38 only, and it has been increased to 121. Okay, and that is because of the loss coefficients. So do you have any doubt so far in like how to write optimization problem in games? Because we just started a very simple problem. In the upcoming classes we will like talk about DCOPF and ACOPF as well, which are bit are slightly more complex problems, and we will try to solve those as well. So do you have any doubts so far? If you have any doubts, you can still put in the chat box, or you can raise your hand. I will unmute you. Now, let's talk about a bit MATLAB. Like we will also see how we can do it in MATLAB. So some algorithm which actually like I explained in the early in the morning. So I'm assuming that you can program it. Okay, that how to program it. I'm not going into that. So I can assume that you can program it. And we will discuss about something else in the MATLAB. Okay, so let me write down the very first line which I write in CLC, like clear everything and clear all the variables. So these are two lines which I usually write. Now, how to optimize with the help of MATLAB. So let me save it on desktop, and this is ELD without losses. Okay, one more thing I missed in the games. I think we discussed that. Okay, what will happen if we are basically solving a market clearing? So in market clearing, we usually give that okay, this is the production level that I am going to produce this much, and this is my block weight, like constant part. So what you can do is you can remove this A and C. So let's say if I put 0 here, 0 here as well, 0, then this is B, and let me make C as a 0 as well. This is what the bits we considered right earlier in the market clearing program. Uh, what was the bits? We had 4 generators. So let me put P4 here. Then we had how much? What was the capacity? 100 each, and minimum was 0. Same, I will put 100 here as well. And what was the cost? 10, 20, 30. So I will put 10, 20. Let's not do it because it's already 5 and we should discuss MATLAB. So first, create an assignment on Canvas and to all the participants, and they have to modify it. So you can give this code as well. So I will provide you this code, and you basically they have to write this code for market clearing program, which we discussed earlier. So I will provide both the codes, like the market clearing one, which I have provided, and they have to create in with respect to sets. So thank you. So okay, let's not go into that and move to the MATLAB. So the lambda iteration method, it's basically simply like some steps are given, so you can use those steps and start writing your own code. You can implement that code with any of the language, either C, C++, Java, and MATLAB obviously, or Python. That piece of code which we have discussed here is basically uh, generalized. So all you need is, I think, if condition, a for loop. That's it. So you have to know, or you should be comfortable, or you should know how to use loops, basically loops and conditions. That is all programming is basically, right? Now what are the different, fast methods? So we should talk about those as well. So let me tell you, there are two functions, or I would say three functions, which we are going to use for this particular course. One is linproc, another is quadproc, and another is mincon. So linprog is for basically, as the name suggests, linear programming. Quadprog is for anyone? Sorry, quadratic programming. Thank you. and F min con is for non-linear programming. Sorry, non-linear programming. Okay, so today we will discuss linprog and quadprog, and fmincon we will discuss when we move to the dcopf and acopf. So I would just, I request you everyone that open your MATLAB, type fmincon and press F1 button on it, so that you can see a help file and you read it. That's it. That how it looks like. So like this help file is there. So like this is a generalized structure of the problem. This should be, and then what are the different input ways and what are the different examples. So it is being provided in the help file. Now we will discuss these two problems. So first of all, I will discuss the linpro. Okay. So how the linpro works. So I have placed. Okay, wait. So function f5. So this is linpro. How to collapse voltage. Let me see. This is the help statement written for the linear programming problems. A linear programming problem is basically a minimization of certain function. So this is, you can see it's minimization of a certain function, and then so it's a minimization of certain function, and such that subject to the constraints is equality constraints, then inequality constraints, equality constraints, and lower bound and upper bound. So let me create a new one, right? Len. Okay, so if you see any standard linear programming problem is basically, the standard problem is always minimization of objective. C transpose X subject to A, or I should use the same syntax which has been provided in the MATLAB. So let me erase this C. It is, I think, F. So it is F transpose X, AX less than equals to B, A EQ dot X is equals to BEQ, and X is less than equals to upper bound, and X is more than lower bound. So these are the basically a standard input function. So let's say X is defined as a vector where multiple variables x1, x2, x3 are given. Okay, and for our particular problem, we can say this is equals to like p1, p2, p3. So whatever is the name, it does not matter. X is a standard a variable. Then in that particular case, f will be equals to a post coefficient. So I would say c1, c2, or let's say okay, c1, c2, and c3. So these are the post coefficients. A is a matrix which represents all the inequality constants. Okay, and AEQ is also a matrix. B and BEQ are vectors, and LBUB is simply by the name, it's lower bound and upper bound. So we had a problem earlier, like market clearing one, and we discussed it. This one, no, this one. This was the problem we discussed yesterday. And if I want to solve it with the help of the, let's say, lin probe, so I have to write down, it's like, instead of maximization, I have to make it minimization. So I will put minimization of certain function and minimization of summation over, it's basically ci. So I have to define certain variables first of all. So what is x? So I have defined x equals to, let's say, p1, p2, p3, p4. Then we had d1, d2, d3, and d4. So this was the variables we had. So I can put it like this, like a matrix here. C1 was 10, 20, 30, 40. So MATLAB is all about matrices. So we have to give our, all the data has to be provided in terms of matrix. So 40, and then we have x. Okay, wait. Then we had 60, I think, for D1. So minus 60, then minus 35, minus 25, and minus 15 multiplied with x. So if I multiply this uh, coefficients, I will get this objective function. But obviously, instead of maximization, I have converted it into minimization. So it's basically CI PI. So this is 10 into P1, 20 into P2, 30 into P3, which is, I think I have mentioned here as well. This one. 10 into P1, 20 into P2, 30 into P3, 40 into P4. Then we changed maximization objective to minimization. So I will put a minus here, and instead of this, I will put a plus sign here. So this is what it look like. Now, what is the next? Do we have any inequality constants? So no, we don't have any inequality constants here, but we do have equality constants. So to use our lin probe function, everything should go in terms of these equations only. Okay, so how we can provide that? So we have identified f. What is the f? If we are solving, let's say, a market clearing example which we have discussed, so f is basically uh, 10, 20, 30, 40, minus 60, minus 35, minus 25, and minus 15. This is my f. Then we have inequality constants. So a and b needs to be supplied, but in our problem here, we don't have any inequality constants because we only have one equality constant. So this is our equality constants, and these are limits. We don't have any inequality constants. So I would say that I can make it like this. So we can basically, okay. So I can say that A is nothing. It's null. B is also nothing. We don't have this. Now A equality. So it is nothing but the equation is basically what? Like all the P1 should be equals to all the demands, and there is no variable like constant term there. So I have defined x here as a like p1 to p4 and then d1 to d4. X is defined like this. I would say aeq will be a matrix, and only one equation is there, so it will be 1 by a number of variables. So it's like p1 plus p2 plus p3 plus p4 minus d1 minus d2 minus d3 minus d4, and beq is equals to 0. That is the for market clearing. lb, so, the lower bound for all of those variables was 0 0. So I will put 0, or instead of doing this, I could have done LB equals to, okay, that we will do in the MATLAB. Then the upper bound was certain. Upper bound was upper bound, I think 100 for all the 4 generators. Then 150 for the first demand, 100 for the second demand, 150 for the third demand, and 100 for the fourth demand. So we'll put those things in the let's say here in MATLAB and try to solve the lambda. So again, I will say, let me press F1. Let me copy this thing from. So let me copy everything from up to this part to this, so that I don't have to type it. Control V. I will control X. And okay, so this is what linpro function will look like. First of all, we have to supply f. So I have defined f equals to what was we have defined earlier, this part, right? So I will put it like this: 10, 20, 30, 40. Then what was minus 60, minus 35, minus 25, and minus 15. This is it. Then we have capital A equals to empty matrix, B equals to empty matrix, and AEQ equals to, we have defined it, 1 1 1 1 minus 1 minus 1 minus 1 and minus 1. So this is AEQ. BEQ was equals to 0. Okay, so this is what we have defined so far. Then we have LB. So LB is equals to lower bound. What was the lower bound? 0. So for everything it was 0. So I would say zeros, and how many times? 1 comma 8. So this is the zeros, and upper bound was equals to, let me place them, 100 times once 1 comma 4. So 4 times 100, then 150 comma 100 comma 150 comma 100. Okay, so we can put it like this, and that's it. Let me run it if it is able to solve. Add to path. Okay, something is there, and let's see the results. So what is the value of x? If you see here in the command prompt, I have kept it open. So x value was 8,000. What we obtained in the games as well, like if we sold this one, run it and look at the LST file, solution report. It was minus 8,000. So obviously we are getting the same result here as well. Then X values are like, the generator 1, generator 2, and generator 3 are given. Generator 4 is at 0. And both the demand 1 and demand 2, the same result which we obtained yesterday. So this is how we look at X value, F value. Exit flag 1 represents normal completion, like, the optimum solution is found. So whenever we are writing down, with the help of MATLAB optimization, if we are trying to solve any, like, let's say, economic load dispatch and all, we try to look at exit flag equals to 1. Then some output is there, like, which method has been used and everything. Then we will look at the lambda. So lambda is available in workspace, so I will open it. And if you see, this is the lambda, and lambda equality constant is coming out equals to minus 30. Okay, so again, it comes equals to minus 30 because um, we have placed, like, instead of PD minus PG, I have placed minus PG minus PD, so that's why the minus sign is coming up. But yes, it is the same market clearing price, 30. So the lambda gives you the market clearing price. Here as well, if you see, like, the equation, uh, the power balance equation multiplier is 30. So you can see this gives you the market clearing price. So yes, the lambda with respect to the power balance equation, again I am repeating myself, we are going to use this statement multiple times, that the dual variable or the marginal value of the equation or the power balance equation, active power balance equation, if the objective functions are cost minimization or the social welfare maximization, will give you the market prices. And if it is economic load dispatch, or let's say like market clearing, then it is MCP, you can say. And otherwise, for DCOPF, you can call it LMP. So we will see how LMPs also work. So do you have any doubts, or should I move to I want to move, like, further proceed to quad proc, how we can use to solve quad proc for economic load, yes, economic load dispatch problem. Any questions? Anyone? So yes, we can move further. So let me just copy it again. So only H is needed here. So let's not go into that. Okay. So what was the input data for our this economic load dispatch problem? So how to write the economic load dispatch problem? So let me take the same data. So I will copy these values here. I think this is it. This is the input data. I will paste them in the MATLAB, but they will not go exactly same. We have to basically play around those. Just place those data. Now let me guide you the input data. So we have first of all generated data. So I will put gen data, and gen data is equals to, I will keep this part, Control C, Control V, enter, and everything should be in form of matrix. So I will define it like this, that okay, this is a matrix and this is the data. I will don't need this part, so it is like, 0. Then shift from delete tab, let me get it. Are you able to see it? Okay, so what was the data? I think I have misplaced. Yes. So this was the data. Right? So this is the gen data. You can comment and explain what is the what is the gen data here. So I can say this is generator data, uh, and columns are basically A, then we have B, then we have C, okay, and then we have P max, and then we have P min. So just for my reference, I have mentioned that these are the, and I will put, okay, gen data. So this is A, this is B, this is C, P max, and then we have P min. Okay, so we have placed it, and let me convert it into matrix. So this is gen data. Then we had control X, control R, control R. Okay, so gen data has been copied. So let me remove this one. Then we have, do we need these? No, I don't think so. Then cost coefficients. So cost coefficients are basically, so if I again go back to this particular economic load dispatch problem and see if losses are involved, then the problem is no longer. So like if you look at this particular problem, anybody tell me how do you define, or how do you know whether the problem is linear, or linear programming problem, or whether it is quadratic programming problem, or whether it is non-linear programming problem? What is the way, or how do we define those? And instead of typing, you can raise your hand. We can unmute you. Ashish, do we have any doubt? Shantanu? I'm pretty much sure that you guys have doubts, so I request you just to pay attention. And if you have any doubts, you can ask me here. Otherwise, it will be very difficult. Like this is very fundamental programming, and we will go for the DCOPF and ACOPF, and to understand that programming will take time. Okay, so if everything is understood, we can discuss it. So the objective function is linear, and all the constants are linear. It is linear. If there is anywhere non-linearity, if the any variable has power except one, then we can call it non-linear. Quadratic programming is a specific type where the objective function can be of a quadratic nature, but all the constants should be of linear. So with losses having a second order function, this with losses problem cannot be solved with the help of quadratic programming problem. For that, we need f min cons. So we will discuss it, I think, maybe tomorrow when we discuss the OPF. Or like while covering OPF, you will be able to basically solve economic load dispatch with uh, losses as well. So here I will not consider losses. So I will get rid of these. And then I have a demand function. So I will simply put a variable uh, PD equals to certain demand. So it is, let's say, 210. Okay. Now nothing else is needed. So this is the data for economic load dispatch. Now we need certain parameters. So first of all, I have to identify number of generators. How many generators are there? So how can we identify? I think let's say n equals to length of gen data, and we can say all the rows comma 1. So this will give me the uh, number of generators. Then what else is needed? I have to make a function f. Okay. So function f will be basically like linear coefficient. So let me define x first of all with a comment. So x is equals to, here we have only like p1, p2 and p3. Only these values are there. So if p1, p2, p3 is there, I can define x and h from the quadratic programming problem. So let's define it. For I equals to 1 to n, and I can define h equals to, it will be a matrix, and that will be of number of generators. So if there are n number of generators, it will be n by n matrix. So the I by I element will have certain value, and rest of the other elements will be 0 for economic load dispatch problem. So I first of all I have to define h. So h is n comma n, and that will be equals to zeros, a matrix of zeros, where the size will be n comma n. Okay, so that has been defined. F will be a vector 1 comma n. Okay, and that will be basically, again, let me define it first of all, zeros, and that is 1 comma n. So okay, I don't need to mention these, right? So h and f has been defined. So I can put hii equals to 2 times of gen data, and then we are talking about ith number of generator, comma, uh, we have c parameter, which is of the square term. So that is available at the third index. So I will put it like this. Okay. Thank you. So I will put it like this. Then we have f. So f will be equals to, sir, screen is less visible as the text is very short. Yes. So what we can do is, let me make it. Can I zoom it? How can I zoom it? Control? I don't have that in my. No. Control Shift plus, no. Hmm? View, no. How? Yes, I have unlocked it. I don't have Control plus option. हाँ, वो नहीं काम कर रहा है मेरे पास में. No. No, let me see. There should be some option here. Expand, editor. Publish code. Control or Alt? No, it is just minimizing the for loop for me. It is not a game, so press Control plus together. No, I have tried that. To work like this. Mm, Can you try this? Yes, please.
व्यू वाले में एडिटर वाले में लिख देते
Delete this one. 10, 10. Control minus.
तो नहीं करता तो वो भी क्यों करेगा
Okay, maybe it's not working. So what we can do is, okay, let me think. Let me think. Can we do that in Word? I will put those the entire code in the Word, and then we can move it. Okay, to the MATLAB. So let me copy paste everything from there to here, so that editor, Control A, Control C. Yeah, but again, I think Notepad, the zoom option will be very less. I think it is visible now. Okay. So yeah, I know, but I think there are some issues that function control plus or control minus both are not working in my laptop. So it's okay. So we have placed paste everything here. So I will reduce the size of this one. So this is our generator data. Okay, and then this is our like information about the generator data. Then P demand, I have identified what are the number of. So let me comment it here. Number of generators. Okay. Then X, I have assumed that my X variables will be P1 plus P2 plus P3. So I have defined certain S, certain F, and then I will write down F function. So let's say for loop I equals to 1 to number of N, and let me end it as well. Then what should I first of all create? H, let's say I comma I comma I, and that will be equals to twice of whatever gen data we have, and then whatever I comma, and the generated data is basically at the third location, so we will put that third location here. So this is basically the H value that will go into our quadproc function. Then F is equals to F, it's a single vector, so I can simply put I, and this is equals to gen data uh, I comma 2. So at second column we have linear cost coefficient, so those will go into f function. So we will put it like this. Okay, then what else is needed for quad probe? So let me copy paste this part, control C. So the quad probe will also need these information. Okay, so instead of quad a lin probe, it will become quad probe, and one extra term h will come here. Okay, which represents the second order coefficients in the objective function. So we had defined a plus bp plus cp square. So the c term will go into h. So this is what we have defined here. Like this c term is at the third column. So this will be multiplied with 2. I will explain you that later on. So it's 2 multiplied gen data. Then in f, the b part will go linear coefficients, and constants need not to be solved basically, because they do not affect the objective function. Okay. Now the next part is we have defined f. Now a. So in do we have a in our problem? No. So I would say a is equals to, there is no inequality constant, so I will define a equals to empty, b equals to empty as well. Okay, b is equals to empty as well. So a and b has been defined. Let me not define as well. Like we can, without that we can use. Then we will define AEQ. So AEQ, economic load dispatch problem, is basically how it looks like. Anybody? Total generation, summation of generation is equals to demand. So how we are going to put it? What will be AEQ in this particular case? Let's say there are 3 generators, and my objective function is summation of generation, which is like P1 plus P2 plus P3 equals to demand. So what will be AEQ and BEQ? Can anybody tell me that? I can unmute you. Shilpa, what will be AEQ and BEQ? This is the standard problem where AEQ and BQs are defined like this. So for economic load dispatch problem, what will be the value of AEQ and what will be the value of BEQ? Gaurav, please unmute Gaurav. I think he has to say something.
MATLAB programming is quite new to me, sir. So
No, but it's okay, Gaurav. We are basically, just trying to learn everything now.
yeah,
So we have to put everything in the matrix form. So
yeah,
we have the equation P1 plus P2 plus P3 equals to PD.
yeah,
Okay, so we have a equation P1 plus P2 plus P3 equals to PD. This is what we have defined in economic load dispatch.
yeah.
Now I have defined X equals to a matrix of P1, P2, P3. Okay, X is a matrix where X is P1, P2, P3. What will be AEQ?
AEQ dot X. Now that's a second equation that we need to define. Loss function is that?
So X is a matrix P1, P2, and P3. and I have a equation P1 plus P2 plus P3 equals to PD, and I have to compare this with this equation X. Now in MATLAB, everything goes in terms of matrix. What will be the value of AQ and what will be the value of BEQ? If I have to put, I will put a matrix AQ here. I will place X. So X is basically it's a transpose, vector, column vector. So I will place P1, P2, P3, and then equals to BEQ, which is also a, let's say, matrix. So
So
what
AEQ
should I
will
multiply?
be
Yes,
AE,
Satya and
AEQ will be
Yan
1 by 1
Yagyan Datta. You are right.
yeah,
Yes, Gaurav.
same thing, sir. What Mr.
So
Tripathi has said.
yes, so like to convert it into matrix, I have to put 111 here and PD here. Correct?
Yeah.
So this is what I'm going to do. I will place like so it will be a row vector of all one. Correct? So I will place F here. A EQ is equals to ones, and the size is 1 comma n number of generators. So I have 3 generators. It will be a row vector of 3, and if it is like 4 generators or 5 generators, it will be number of generators. So I'm writing a generalized code here. Then we have a BEQ. Okay, so BEQ equals to we have our PD defined here. So this is a PD which we have defined over, which is 210 here. Now what else is needed? LB and UB. Yes, so we have defined H, we have defined F. A and B will be empty. AQ BEQ has been defined. What will be LB and UB? So from the data, this is LB and this is UB, so I can simply extract those one, that LB equals to gen data all rows comma 1 2 3 4 5. 5 is the lower bound, and then control C, control V. This is our upper bound, and that is at 4th number column. So this is column number 4, right? So this is what we have defined. So everything is all defined, and we can solve it now. So I will copy paste everything there. Anything else is needed? I think no. Control A, control C, and I will put it in the MATLAB. So control A, control V. So you can see this is how it looks like. Okay, so the quad pro, these all are output parameters, and the input parameters we have defined. So H has been defined, F has been defined, A is not defined, so I will place it here as well. So there are multiple ways, like you can define A and B above, or if it is empty, you can directly place them here. And let me run it. So let's hope there is no error. I must have written correct code. So yes, there is no error, and exit flag is 1, and certain output is there. So 50, 88, and 73 without loss, we sold it, right, already. Note in this particular part, section 1. So without loss was 50, 88, and 72, and lambda was roughly around 11.89. And let's check in MATLAB as well. So 50, 88, and 72. So the same values are here as well. Okay. And then we have basically a function value. So it's a 2000, and basically 10 to the power 3, so 2393.3. Exit flag is 1. Now system price, that is in that that is the one thing which in which we are interested. What is the value of lambda, which is system price? For lambda, we have to look at the lambda part. So this is available in function, and lambda is for the equality constant. So it is also coming out equals to 11.8989, which we have solved with the help of games as well. 11.8989 was the exact values. Okay, so this is how we can solve for using with the help of the quad probe. Is this clear so far? Now I want to
But
check who's online. We want to basically discuss who's actually doing programming with me. Like, I'm doing along with you just so that you can learn more. If I could have, yes, but we are writing a very fundamental programs, right? It's not very large programs, and I'm writing with you only. So it is not, like very lengthy code. Yeah, why we are doing this in both? So both are two different basically softwares, and you can use them. It depends basically like how much freedom. Okay, who can tell me like what is the difference between games and MATLAB? Anyone? You can just you don't have to type. You can just raise your hand and I will unmute you. So anyone like who can tell me like so far what difference you have found in either games or MATLAB? I can ask these programs in the quiz as well. Okay, so just to explain you like what is the difference. So if you have seen in games, we are writing equations just like we are writing in our notepad as well. Like we have written losses is equals to v note summation over I and like bi note plus into pi. Similarly, summation over I and j. So double sum was there. Then pi, bij, and pj. So this is how we are writing earlier, like the equations exactly same. Okay, we are just defining everything that okay, these are the input data, so different sets, tables, parameters, and then we have defined certain equations. We have written down those equations exactly same as we are writing in our notebook, or let's say we are like writing in our some mathematical tool, like Word or some Mathematica and all. Okay, so in MATLAB it's a bit different. So if you see in MATLAB, I have written the same problem like this. Everything is defined here, this highlighted part. This is where everything is defined. Does it look like what we are writing as in our notepad? No, right? It does not look like. So in MATLAB, basically, you have to look for, like how the different entries will be given. So like quad prog has a particular sequence. Like first of all, you have to supply h. If I replace like whatever h I have defined here, and if I have placed f here, it will not understand it. It will give you the wrong results. It will definitely give you very wrong results, and maybe it will not converge as well. It will not solve anything. You have to follow this particular sequence, and this can be understood by this particular like syntax thing. So either at least you have to supply h and f. Then if you need a and b, then you have to supply h, a and b. If you don't have, let's say A and B, but AEQ and BEQ, then you have to go up to this particular part. Okay, at least this particular part you have to mention. If you don't have any bounds, like variables are free, like minus infinity to plus infinity, you don't have to put lower bound, upper bound. It's completely fine, but you have to write it up to this. But what happens, like if I don't have any inequality constants, then A and B are empty. I don't have them, so you have to place empty, just like we did it in our economic load dispatch problem, where we don't have any inequality constants apart from the upper bounds and lower bounds. So everything is in particular syntax, in a particular sequence has to be provided, and the logic is needed to formulate these metrics. So, like for economic load dispatch problem, it is very simple problem, and you can easily make these matrices. I can either you can simply type those, or you can put some simple logic as well to formulate these matrices, and then you can basically start solving it. So MATLAB is bit complex as compared to games. Let me tell you that. But the benefit is we have MATLAB all around us. Like in almost all the institutes they have MATLAB licenses, and you have with you as well. So like we all have MATLAB. So it is accessible. MATLAB is easily accessible. About games, you have to pay for it. So the very demo version can solve a very limited number of variables. So if I see how many variables we can solve, academic license is there. So yeah, but apart from academic license, it's very difficult to get the uh, game software. It takes a lot of money. Basically, you have to pay, but it's good. Games is also good, like very simple way of writing. Everything is neat and clean, and you have many like flexible like different type of the way different types of problem you can easily solve without looking into what it is doing inside. You don't have to write the logic, but flexibility is not there. Let's say I want to change some algorithm. I want to make some updates in between the algorithm. Like let's say I want to accelerate some algorithm. So I have set some logic and I want to implement that logic. Then you have to write a program of your own for a particular algorithm. That thing you can do with the MATLAB, because in MATLAB it's very easy. Python can be used. Yes, Python and MATLAB both can be used. Python is again open source. It's free of cost. So Python is very good. So Python is very good. It's robust. A lot of help files are there. Even like if you use this what Gemini and Colab, it can suggest you the codes as well. So Python is also very good. Okay, but for optimization point of view, like solving complex optimization problems, so these like economic load dispatch is very simple. It has we don't need games to solve it. You can easily solve like a simple C program with the lambda iteration method. It will give you the same answer. But just to I use these examples just to understand the syntax, how we can use the particular softwares. So if I'm going with the complex uh, optimization and like lot of variables, I'm talking about thousands of variable, not less than that. So if thousands of variables are there in MATLAB, all the matrices will be of thousands, like 1,000 by 1,000 size, and those range basically. Here you can easily do it in games. So if the size of the optimization problem is very large, it's better to use games if you have it. Otherwise MATLAB is also fine. So that's why we are learning these two softwares. Okay, and apart from that, the flexibility is there in MATLAB. Like I prefer, like I'm comfortable in MATLAB, and I assume like I can play with the code. I can, whatever is the existing like piece of code available there. I can mold it, turn it as per my way, and it's a very like the lot of freedom is there in here, and then just run the click button. The entire algorithm is already in the server and in the backend, and they will solve it for you. So if you are going for a very complex and a well-defined problem, then it is good using games. And if you are solving your own problem, and maybe a certain algorithm is there, like it is changing dynamically, like entire problem is changing very much dynamically, then over the iterations, let's say it is changing, then MATLAB or Python is better. Okay. And any other question so far for economic load dispatch? So just a quick update. There is a issue with the sir. What will be the topic of tomorrow's session? Yes. So tomorrow we will talk about the optimal power flow. So it is basically you can say economic load dispatch with network. So first of all, we will see a simple one. And one more thing is tomorrow's session will be of 2 hours in the morning. So I will share the updated schedule with you, because in the morning we have to accommodate the 3 hours which we have earlier put on the 26th of January. So it is holiday. So let's not waste holiday for you. I am free, so I can be available. Like if you want, but yes, academy will also be closed, so it will be very difficult to organize the sessions. So we will accommodate those two. And there is one more issue that around 4 to 6 some meetings are there, and we have certain only limitation on the license of this WebEx. So 4 to 6 slot is not available anymore. So we will complete the entire course, like whatever is the 4 to 6, between 2 to 4. Okay. So I will share that entire timetable with you, that instead of 4 to 6 it will be 2 to 4, and then around 4 we will be free. Saturday timetable will remain same. There won't be any change in the Saturday's timetable. And for 3 days I will take 2 hour morning class instead of 1 hour. Okay. So tomorrow we will talk about DCOPF and like hands on that. So I request be bit attentive for that one, because it's a bit complex and it is very interesting. Okay. So we will learn a lot. Okay. Evening session will be 2 to 4. Just no, it will be for the entire course, 2 to 4 instead of 4 to 6. Okay. So the entire course is being shifted, instead of 4 to 6 to 2 to 4, the evening sessions. Okay. There will be one assignment for you. Okay. So you can check your Canvas uh, like account, and there will be one assignment posted. So whatever we have done, this programs I will share with you as well. I think we can share it on the Canvas. Push. We can share the material on Canvas, right? So I will share these codes with you on the Canvas. uh, just play around it, try to change it. You will see a lot of errors maybe. Okay. And if you see them, you will learn a lot. Okay. So just play around it, so that it is beneficial for our next class. Like we have to write a bigger code for DCOPF, which is bit bigger, and trust me, uh, it will take time. So I request you that go through all of these courses. Apart from that, if you have any doubts about the market clearing and how we can like economic load dispatch. You mentioned something about unit commitment in the morning. Yes. So We will discuss unit commitment as well, but unit commitment problem is highly, I would say, yes, we can linearize it, but it's a mixed integer one. So solving it is very difficult, I would say. Like, like from the teaching, explaining from the very beginning. So we have, first of all, we are going for the easy problem. So economic load dispatch is very easy. So that's why we picked it, this one. Then we will go with the DCOPF in continuation ACOPF, and then we will come back to the unit commitment as well. But the sequence about the unit commitment. So in the morning, we discussed that there was two units, I think, and each has the capacity of 150. And I asked you that can you solve economic load dispatch for a load of 350? And the answer was, if we have renewables, can we still follow the same style of ELD? I will explain you the renewable as well. Okay, so yes, first, Satya, I will just answer the Gaurav that like about unit commitment, and then I will come to your question. So about unit commitment, so like for the entire day, we have a like rough estimate of the what will be the demand and what will be the reserve requirements. Okay, so for that, and again, like uh, estimations are on the upper scale only. So with that particular estimation, we commit, the system operator commits certain units. So that is what the unit commitment basically take care of. And somebody mentioned in the one question as well, like how the ramp limits will affect. So yes, we cannot increase the production from 0 to, let's say, 100 megawatt instantly. It takes time. Okay, because it's a mechanical generator, so and production has to be increased over time, so it takes certain amount of time to increase the production. So those are called ramp limits. So let's say you a particular hour you ask that, okay, generator number 3 should produce very less amount of power, and then uh, another generator will produce certain like we have to turn it off and we have to again turn it on. So you cannot do that. Okay, so those things like ramp limits, and sometimes what happens, like if you turned on a unit, you cannot turn it off the next hour. You have to keep it on for a certain minimum amount of time. So everything, like all those highly integer type of problem, or basically I would say integer type of uh, attribute of that particular problem, is solved in unit commitment. So a day before the actual like power delivery, the system operator commits certain like units or power plants basically, that okay, you have to be online. Once those generators are online, then we perform economic load dispatch. So in actual system, it can never happen that the demand is 350 and only 2 units are available which can only supply 300, because the estimate will always be there that okay, there will be certain demand of 350, and for that demand the system operator will keep at least 3 or 4 units committed well before, and then uh, out of those 3 or 4 units we have to perform economic load dispatch. So then economic load dispatch will give you the final set point that okay, this much a generator has to be produced. Okay, so if anything else is needed on unit commitment, Gaurav, you can type in the question. Then Satya asked that if we have renewables, can we still follow the same style of economic load dispatch? My answer is both. Just yes and no, both. Yes is if a renewable can stick to its schedule, we can perform economic load dispatch, because the cost is zero. So the cost functions are, you can say A, B, C, all are zero. We can assume that okay, all are zero, and we can simply assume like as extra P renewable or P4, which is renewable generation, and we will put that in the equation. So renewable economic load dispatch can be done for with renewable as well. Uh, and the cost coefficients can be assumed that okay, yes, for renewable there is no cost involved, or very negligible cost is there, so yes, we can do that. But the thing is, economic load dispatch, so far the units which we have considered had certain cost function, and these are usually thermal units. Okay, so thermal units are quite reliable. That if I ask them to produce a certain capacity, let's say like we obtained how much 72 megawatt for the third generator, right? So if I ask a generator to produce 72 megawatt, it will produce 72 megawatt. It can stick or it can manage to produce a fixed or amount. But what happens that if I ask a renewable that okay, you have to produce 72 megawatt, it's highly uncertain. So uncertainty is there. So in that case, we can again follow the same principle of market. We discussed that okay, in perfectly competitive market, every participants are price taker and they are not price maker. And same goes with the renewable as well. Renewable does not have any cost, so it can never affect the prices. The cost function is zero. Okay, but the quantity is keep on changing because of the uncertain and highly volatile nature of the renewable. So it can self schedule itself that okay, a renewable can only that okay, this will be the market price, and based upon market price I should produce this much, and whatever is the forecast based upon that, a renewable can self schedule itself, and the objective will be profit maximization only. So it's basically like like renewable can self optimize everything, obtain a schedule and submit it to the system operator that okay, this is the schedule I'm going to follow. Okay, so that uh, it gets maximum profit, and it does not get any penalty, because there will be penalty for deviation. So if renewable deviates, there will be penalty. Okay, so it can basically minimize the imbalance. Certain deviation is allowed as per the regulations. Different countries have different regulation and different allowed range, like 5 plus minus 5% or 10% is allowed, but more than that you have to face penalties. So yes, if you want to do ELD with renewables, if you a renewable power production company is certain that okay, this is this much power output can be maintained, yes, we can do economic load dispatch as well. And if it cannot commit that okay, it is highly uncertain, so that's why we do not prefer. We assume that okay, this much renewable will be there, and we demand is also like highly unpredictable, it's uncertain. So that renewable part is basically moved to the demand, net demand, instead of the actual demand. We can basically perform the economic load dispatch for the net demand, and net demand is basically inclusive of renewable as well. So I think that should answer Satya as well. Anyone else, do you have any question? Deviation penalties are the reason for our Indian government to ask for firm dispatch renewables. Yes. So there are basically evolution, I would say. Earlier, we had very less, uh, I would say very, so the division penalty in the reason for the our government asked for the firm dispatch renewable. Earlier, the renewable like solar and wind were very less in the system. So the government was encouraging everyone that you should, come up with the power plants, renewable power, and inject into the grid. So whatever they were injecting, they were getting paid a certain price for that renewable, and system operator was managing that. Okay, if this renewable goes out or that entire uncertainty, uh, the system operator was managing with respect with from the reserve capacities. Now we have reached like very high renewable. So if it is very high, then they can no longer be treated as a like baby, and they can no longer be have the privilege of producing whatever they want and get the money. So because of that, because let's say in the daytime, as Professor Bhakkar also explained on the very first day, we have lot of solar potential. But what happens that a solar plant decides to not inject anything. For that, a system operator has to keep a reserve. So one generator is basically there to supply that one. Okay. So whoever is deviating from that dispatch should face some penalty. So that's why, just to make everyone answerable, that okay, if you have committed this much, you should produce this much. Okay, so instead of going with very high commitments, come up with a medium commitment, and we will discuss, like I will explain that as well. Like we have one renewable scheduling, and I will discuss the entire maths how a renewable generation power plant can make a firm dispatchable schedule for itself. Okay, so we will discuss that as well. I think we have a renewable scheduling problem as well. One of the session is on that. Like on in the Europe, basically there are many countries which are basically producing more than 50% of renewable, and if they do not make them dispatchable, the system operator will face a lot of problems. All the frequency variations, deviations basically, and voltage deviations as well. So it has to basically keep lot of resources to supply those variations from the renewable. So that's why they are asking for renewable to become dispatchable, or whatever you have committed you should provide that. And that can be, what can be the instrument like to make a renewable dispatchable? How can we make renewable dispatchable? Anyone? Because it's the inherent nature of the renewable that it is going to vary. Yes. So batteries or storage are one answer. And yes, there are a lot of pilots are going on, and there are a lot of plants which have this facility. So we have storage integration session as well. So uh, I will again provide maths only, like it's not like theoretical that okay, storage, we will use storage for charging and discharging. I will provide you the background mathematics and how to solve it as well, just to if you are like how it works basically, just to get the glimpse of that. So we will talk about that in the, I think one of the session is about the storage integration. So in that session we will talk about it. So again, I let me repeat myself. Tomorrow's class, morning class, is also of 2 hours. It will be 10 to 12, and then we have like all the evening classes, which was 4 to 6 on the following days, are moved to 2 to 4. And by, I think, after certain time, I will send you the updated timetable. Thank you very much. And if you have doubts, you can email me as well. Like you can send me your detailed doubt, and we can discuss those as well in this particular class. I think Shilpa asked about multiple objective optimization problems, but we have lot to cover, so it will be very difficult for me to cover that as well. However, I will try to provide that if it is like possible somewhere on the Saturday maybe. And apart from that, yes, there was one more question. Can GAMS can be used for meta heuristic algorithms? So I gave answer yes, it can be used, but it required a lot of effort. So I would not use games for meta heuristic approaches. Okay, because a meta heuristic is what, a logic where you have to solve everything over and time, basically time over multiple times, and it is just loops and conditions. So yes, games also has loops and conditions. So if you can write those logics, you can solve meta heuristics as well, but it is very complex. So I would not prefer, or I would not recommend to use games for meta-heuristic, because it is already very much advanced, and lot of solvers are there which can handle almost all kind of optimization problems. So you don't need to solve a problem uh, with the meta-heuristic algorithms, because the games is very good in that. It can solve anything, almost anything. So that's it from my side. Thank you very much, and we will resume tomorrow at 10 o'clock. Okay.